Our next presenter is Shanka Subra Mahanti, a doctoral student in geosciences. Shanka, you have the floor.
1, 2, 3. Over 50,000 people died in Turkey and Syria last year due to a big earthquake. Earthquakes are deadly, but for geoscientists like us, those are important tools to understand our planet. Now, if you look at numbers, in last 10 years in the United States, we saw one big earthquake with magnitude higher than 7. Now, these big ones, they give us a lot of information, but for a very specific region and after creating so much damage to our planet. Now, at the same time, we had nearly 80,000 earthquakes with magnitude higher than 2 and possibly 10 million earthquakes if we consider all the magnitudes. Now, these small earthquakes, you probably cannot feel those and mostly not damaging, but those can give us really important information about our planet as well as future earthquake hazard compared to one big earthquake in 10 years. Now, the problem is, out of those millions of small earthquakes, we usually detect nearly 10% of them. Because when you look at data, a big earthquake might have a very clear signal, whereas a small earthquake may not be that obvious. So the question is, how can we detect those small earthquakes? One solution is to have an expert who would scan through the data and find these for us, but that's super time consuming and can take like months or years. So for my research, I am applying this modern tool, artificial intelligence, which is essentially a computer algorithm that can mimic human intelligence and find these earthquakes for us in a really short amount of time. Now, as a case study of this, I applied this idea in a small region in central South America on the Andes Mountains, where I could find more than 2,600 earthquakes using AI compared to previous studies which only found nearly 230 earthquakes during the same amount of data sets. Now, using these small earthquakes, I'm trying to understand some bigger geologic questions, like how did the Andes Mountains form and how are those deforming right now? And also, how does the deep earth looks like in those areas? But eventually, we will extend this idea to more populated regions and which are mostly earthquake prone, where if we find these small ones, those would give us important information about the ground shaking so that we are better prepared if a big earthquake affects in near future.